What are the neurobiological differences in the ADHD brain? Imagine your brain as a busy city with roads, traffic signals, and communication systems. In the brain of someone with attention deficit hyperactivity disorder, or ADHD, some of these systems work a little differently. These differences help explain why paying attention, controlling impulses, and staying still can be more challenging. First, look at the structure of the brain. Key areas involved in focus, behavior, and movement tend to be smaller or less developed in individuals with ADHD. The prefrontal cortex, which helps with planning, decision-making, and keeping attention, often matures more slowly and is slightly smaller. This can make it harder to stay focused or control impulses. The basal ganglia, which helps regulate movement and behavior, is also smaller. The cerebellum, which contributes to coordination and thinking skills, shows differences too. These structural variations are common and can be seen in brain scans. Next, consider the chemicals in the brain. Neurotransmitters are chemicals that carry messages between nerve cells. In ADHD, there are often lower levels of dopamine and norepinephrine. These chemicals are important for motivation, feeling rewarded, and paying attention. When their levels are lower or their pathways are disrupted, it becomes harder for the brain to focus or stay motivated on tasks. This chemical imbalance is a big part of what causes the symptoms of ADHD. Now let's talk about how the brain functions. The brain has networks that help us pay attention and control our behavior. In people with ADHD, the default mode network, which is active when the brain is at rest or daydreaming, tends to be more active when it should be quiet. This overactivity can pull attention away from what needs to be done. Also, the connections between different parts of the brain that handle attention, memory, and movement are often weaker or less efficient. This makes multitasking, planning, and impulse control more difficult. These differences in brain structure, chemistry, and function are not about making poor choices. They are real biological features of how the brain develops. Many of these differences stay into adulthood, which is why ADHD symptoms often continue over time. Understanding these neurobiological differences helps educators and support staff create better strategies. For example, breaking tasks into smaller pieces, giving frequent breaks, and using positive feedback can help children with ADHD succeed. Medications that boost dopamine and norepinephrine can also improve focus and impulse control. Recognizing that ADHD is rooted in brain differences allows us to support individuals in ways that respect their unique needs. It's about working with how the brain is wired to help everyone reach their full potential.